right, this is 7.6 part 3. So it's been really fun learning how to do Gaussian elimination and that whole process. But now I am going to show you how to do that in the calculator. That doesn't mean that you won't need to know how to do Gaussian elimination because as you know, I could ask you to show work and I could be checking your work for credit. Or I could put some conceptual questions on the test where you have to know the process and understand Gaussian elimination and row operations with matrices. But I am going to show you how to do it in the calculator now. So here's how we do this. First, you want to create an augmented matrix. So taking your coefficients 4, 1, 6, 7, 3. This is a typo. This 7 was supposed to be a y, so hopefully I fixed that on your notes. That should be a y there. So just 3 to 17. Negative 1, negative 1, 1, negative 9. Okay, so we've got our augmented matrix. Now we're going to enter that into the calculator. So to do that, hit second matrix. Matrix is right beneath math. So second matrix, over to edit. Hit enter. We're just going to enter it as matrix A. You need to enter the dimensions of your matrix. So it's rows by columns. So I have 3 rows. And I have 4 columns, so this one is a 3 by 4. It's rows by columns. So 3 enter, 4 enter. Now enter all of the entries of your matrix. Now you want to hit second, quit to get out of that screen. So that's step 1, enter your matrix. And then you're going to go get row reduced echelon form. You can do either row echelon form or row reduced echelon form. But as we know, row reduced echelon form is the one that gives you the answers in the far right column. It's the one where you have the diagonal of 1s and 0s above and below. 0s above and below. Okay, so I want to do that one, but your calculator can do either one. So hit second matrix, which is x to the negative 1 there again. Go over to math. So the first time we went to edit, the second time we're going to math. Scroll up because what we're trying to get is near the bottom. Okay, and then you see B, which says RREF. That is going to give you row reduced echelon form. If you did A, that would give you just reduced echelon form. Hit second matrix a third time and just grab that matrix. We entered our matrix in matrix A, so we're going to use that one. And there's your matrix in row reduced echelon form. Okay, so I'm going to write that down. Okay, so my row reduced matrix is 1, 0, 0, 4, 0, 1, 0, 3, 0, 0, 1, negative 2. So as you can see, putting it in row reduced echelon form gives you those zeros above, both below and above the diagonal of 1s. So what we have here is x equals 4, y equals 3, and z equals negative 2. Okay, so x, in this first row, we've got x equals 4. In the second row, it says y equals 3. And in the third row, we've got z equals negative 2. So the ordered triple is 4, 3, -2. And that's how you can do that in your calculator. Let's try another one. So number 7. First, we need our augmented matrix. And so first you need to make sure all of your equations are in standard form, x, y, z equals a number. It looks like we need to fix this second equation because it's got x, z equals a number plus y. Okay, that's not going to work. So I'm going to subtract the y over. Just subtracting that y over gives me 2x minus y plus 2z equals 15. Okay, and I don't need that one anymore. I just adjusted it. Okay, so let's get our augmented matrix from that. That's going to be 1, 4, -1, -7. I'm going to do this -3 first because remember the order of your equations doesn't matter. You can swap out rows. There's no y in this equation, so we're going to put a 0 there. All right, now we're going to put that into our calculator. So hit second matrix, go over to edit. This one is also 3 by 4. Okay. Now second matrix over to math. So first you do edit, then you do math, then you do names. You kind of work your way backwards. Now on math is where we grab our REF. Then we grab our matrix A. And there's our row reduced echelon form. So that's going to be 1, 0, 0, -5, 0, 1, 0, 3, 0, 0, 1, 1, 4. All right, so it looks like we've got x equals -5, y equals 3, and z equals 14. So -5, 3, 14 is that ordered triple. That is the point where the 3 lines intersect. Now let's do a couple of applications, and we're going to use our calculator to solve these as well, but you do have to be able to read the problem, set up your equations in order to solve. So number 8, every day a cupcake store sells 5,000 cupcakes in chocolate and vanilla flavors. So total they're selling 5,000 cupcakes. If the chocolate flavor is 3 times as popular as vanilla, how many of each cupcake sell per day? So our variables need to represent the number of cupcakes. So I could say C equals chocolate. Oops. Chocolate cupcakes sold per day. And then V equals vanilla cupcakes sold per day. All right, so my first equation, they sell 5,000 cupcakes total, so that's going to be chocolate plus vanilla equals 5,000. A lot of cupcakes. And then they say the chocolate flavor is 3 times as popular as the vanilla flavor. So be careful with this one because our instinct might be to say chocolate is 3 times more popular than vanilla. But that's incorrect because then you're saying if they sold 1 chocolate, they would sell 3 vanilla, right? If I plug in 1 for C, I would get 3 for vanilla. But that's not right. it says chocolate is 3 times as popular as vanilla, so we should be selling 3 times the number of vanilla for chocolate. So that should be chocolate equals 3 times vanilla. That way, if I'm selling 1 vanilla, I'm selling 3 chocolate. That's 3 times as many chocolates as vanilla. All right, so now in order to put this in matrix form so that we can solve it in the calculator, you would want to get this in standard form. So I need to subtract my 3v. Okay, so that gives me chocolate minus 3 vanilla equals 0. All right, so now I have my 2 equations that I can put in matrix form, now that they're both in standard form. So 1, 1, 5,000, 1, negative 3, 0. You could also solve this using substitution or elimination or whatever you want, but we have a calculator, so I'm just going to do it this way. That way, hopefully we don't make any mistakes. Okay, this one is a 2 by 3, 2 rows, 3 columns. Okay, got my matrix, second quit. Now go to matrix again, over to math. Oops. And then up to RREF. Go to matrix one more time, get your matrix, and hit enter. So I've got 3750. Okay, I'm just going to write this down. 103750 01 1250. Okay, so remember that first column that we had was our C, chocolate. So these are our C's. So this is saying chocolate equals 3750. And then the second column was our V, so that's saying V vanilla equals 1,250. And so that's what you've got there. You've got 3,750 chocolate and 1,250 vanilla. And I want to write that a little bit more properly because chocolate C and V were not given to us in the problem. I made those up, so I don't want to use those as part of my answer. 3750 chocolate and 1250 vanilla. All right, let's do one more. A small shoe company took out a loan of $1,500,000 to expand their inventory. Part of the money was borrowed at 7%, part was borrowed at 8%, and part was borrowed at 10%. The amount borrowed at 10% was 4 times the amount borrowed at 7%, and the annual interest rate on all 3 loans was $130,500. Use matrices to find the amount borrowed at each rate. So I'm just going to let X be the amount borrowed at 7%. Y is going to be my amount at 8%. And then Z is going to be my amount at 10%. Okay, so total, we are borrowing 1,500,000, and so that's going to be X plus Y plus Z equals 1,500,000. Okay, our next equation. The amount borrowed at 10% was 4 times the amount borrowed at 7%. So the amount at 10%, that is Z. It says that it is 4 times the amount borrowed at 7%. So 4 times X. the amount borrowed at 7%. And then we have that the annual interest on all three loans, so altogether the interest that you're paying in 1 year is $130,500. So the way you calculate that is by multiplying each amount, X, Y, and Z, by their corresponding percentages. So that's going to be 0.07x plus 0.08y plus 0.1z. So that gives me my annual interest for each amount. And that sum is going to be $130,500. All right, so those are my three equations. Now I'm going to put those in matrix form, use the calculator to solve. First, we need to get this second equation in standard form, so I need to subtract that 4x to the other side. So negative 4x, there is no y, so you can put plus 0y plus z equals 0. Okay, so just change that up a little bit. Okay, and let's write that as an augmented matrix. 1, 1, 1, 1, 5, 0, 0, 0, 0, 0. Then I've got negative 4, 0, 1, 0, 0.07, 0.08, 0.1, and 130,500. Now we'll use our calculator to solve that. So hit second matrix, over to edit. This one is a 3 by 4, 3 rows, 4 columns, so 3 enter, 4 enter. All right, so there's our matrix. Second quit, hit second matrix again, go over to math, scroll up to B, then go grab your matrix A, and there we are. Sorry, I actually just noticed that I left off a 0 on this entry here. It's supposed to be 1 million and I put 150,000. So let's just add one more 0 there. All right, so let's try that again. So over to math, up to RREF. Oops, not right here. That's why you have to hit second quit. Actually, what you can do is just scroll up and hit this RREF of A, because that's what I'm wanting to do again. There we go. I thought that there was something wrong because I had some weird numbers as my answer, so it's always a good idea when that happens to just go back and check the matrix that you entered in the calculator, because there's always a chance that you just mistyped something. All right, so we've got 1, 0, 0, 1, 5, 0, 0, 0, 0, 0, 1, 0, 7, 5, 0, 0, 0, 0, 0, 0, 1, 6, 0, 0, 0, 0, 0. Okay, so let's answer the question now. So remember, 1 was X. First column was X, and X is the amount at 7%. So they borrowed 150,000 at 7% interest. Then they borrowed 750,000 at, so that second column was Y, so that is my 8% loan. And then they borrowed 600,000 at Z was my 10% loan, so 10%. And that's your answer. All right, that's it for 7.6.